Okay, this video is a review for the fall exam that you will be taking this week. All right, so for the first 6 questions, we're actually going to be using this graph here. This is the graph of this equation, f of x or y equals 2/3 x minus 2. And it's graphed here. Now let's go and take a look at the questions. First, question number 1, which point represents the graph's y-intercept? Well, this is the y-axis. So the point right here where the graph crosses the y-axis is the y-intercept, and the y-intercept's at -2. The point technically would be at 0, -2. All right. Now the next question, which point represents the graph's x-intercept? Well, the x-intercept is where the graph crosses the x-axis. This is the x-axis. You can see it crosses here at 3. 0, this point is actually called 3, 0. So the answer there, again, would be 3, 0. All right, now, which point represents the graph's 0? Well, the x-intercept is actually the same thing as the graph's 0. This is called a 0 because when you plug in 3, the output is 0. 2/3 of 3 minus 2 is going to give you 0. So that's really the same answer there, 3, 0. All right, now question number 4, the above graph represents a function, true or false? Okay, so a graph is a function as long as each input only has one output, okay? Now this is a linear equation, and you can tell that it is a function. One way we can do that, if you draw a vertical line test and it only goes through the graph in one place all throughout the graph, then it is a function. But you can see here that there's not any repeating outputs for one input. So yes, this one is true. We do have a function. All right, and then what is the domain and range of the given graph? Okay, the domain is all of the x values. Okay, so the domain is all of the values that horizontally are on the x-axis. So you can see here it starts at -3. And then it continues going to the right, and it'll go forever because of this arrow right here. So the domain, or all of the x values, are actually all real numbers that are greater than -3. Now this is an open circle, so it can't be greater than or equal to. It actually has to be greater than -3. So there's different ways we could write this out. But one thing we could say is that all real numbers are greater than -3. Again, the domain is all the values on the x-axis, or all the input values. So it starts here at -3, but it's actually an open circle. So everything, all real numbers greater than -3. All right, and then what is the range? Well, the range is the y values. And the y values are the values that go from the bottom to the top. So the lowest y value here is -4. And it goes up, and again, it has an arrow, so it's going to go up forever as well. So the range, or the y values, is going to be all real numbers greater than -4. Okay, and then finally question 6 for this graph says, using the above function, evaluate f of -3. Well, f of -3 basically just means you plug in a -3, and what is the output? Well, on the graph, when x is -3, you see the output of -4. So again, when you evaluate if f of a number, this number is the x value, you plug that in. You could plug it in the equation and see what you get, but on this graph, you can see it, that it's actually -4. So the answer to this one would be -4. All right, let's move on. Okay, so in these questions, we're going to use this graph, or all of these equations, to answer questions 7 through 11. Now, question 7 says, which of the following graphs has a y-intercept of approximately -1.5? Well, if you understand what y-intercept is, you just take a look. We have the y-axis. The only one here that is negative is this green one. So this green graph, which is C, has a approximate y-intercept of 1.5. So we'll call that C. All right, question number 8. Which line has a 0 of 3? Again, this is a review of what a 0 is. 0 is the x, another term for the x-intercept. So you can see the x-intercept here is 3. You can actually see that line A or line C both have an x-intercept of 3 or a 0 of 3. So we could put green or red or C or A. So let's say C and A. All right, and which line has a slope of 3? Which line has a slope of 3? Well, again, to find the slope, we're talking about the rise and the run, okay? So when we go from point to point, so let's look at the green line first. Here's a point on the green line, and then here's another point. We would have to go up 2 and over 4, which is actually up 1 and over 2. So the green line has a slope of 1/2, okay? Notice the red line is negative, so it has a negative slope, so there's no sense in even considering that one because the question number 9 says which line has a slope of positive 3. So it must be the blue, and you can see here from the y-intercept at 1 and then the next point, we do go up 1, 2, 3 units and over 1. So it's the blue line B that has the slope of 3. All right, question number 10. Which two lines have -1 and -2 as the solution to their system of linear equations? Okay, remember, a solution to a system of linear equations is where the two equations intersect. So we're simply going to find the point at -1, -2, which is -1, -2. And you can see there that line B and C, the blue line and the green line, intersect at -1, -2. That means this point is a solution to that system. So our answer is going to be line B and C. All right, question number 11. What is the equation for line A? All right. Okay, so the first thing we could take a look at to find the equation of line A is to look at the y-intercept. So the y-intercept is 2. So in our equation in slope-intercept form, it would have a +2 at the end. So actually the only one that has a +2 is B. Okay, and this is in y because the mx plus b form, and you'll see that the slope is -2/3. And on the red, if we go from the y-intercept to the next point, we do go down 2 and over 3, so it does have a slope of -2/3. So you see that B is the answer, or is the equation to line A. Okay, let's take a look at this question here. Number 12 says, Susie runs a business. She charges $45 as her initial fee, then $15 for each item she makes. Write the equation that represents this situation. Okay, so basically what we have is her slope here, or her constant rate of change, is that she charges $15 for each item she makes. But it does say that she charges $45 for her initial fee. So before she even makes an item, she's at $45. Okay, so that's going to be our y-intercept. Let me just think about it being graphed like this. Again, if she hasn't made an item, she charges that additional $40 fee, and then it starts to go up from there at $15 per hour. Her slope is 15. So the equation is y equals mx plus b. Y equals the $15 per item that she makes plus the $45 initial fee. All right, this question says, which step contains the error in finding the solution to the situation? So basically, for this review's sake, I've just given you a couple of examples here where some students where it shows some students making mistakes. You can see the very first thing here, we have an equation, 6 times x plus 4 equals 3x minus 2. And this student, it looks like they chose to subtract 6 from the right side over here, but they never distributed the 6. So 6 times x and 6 times 4. Over here, similar, it looks like they multiplied 6 times the x value to get 6x, but then they did not multiply 6 times 4 to get 24. So on the exam, you'll be looking at some different students who made mistakes, and you'll find which one made an error in finding your mistake. Now let's go and take a look at this question. I'll show you how you specifically do solve it. All right, so we have an equation, 5 times 2x minus 3 plus 4 equals 4x minus 5. Okay, so in this equation, we have variables on both sides. And the first thing we're going to need to consider is that we have to use this distributive property over here. So 5 times the 2x minus 3. Well, 5 times 2x is 10x. And then the 5 times negative 3 is going to be minus 15. And then we have the rest of our equation, plus 4 equals 4x minus 5. All right. Well, now we have some different options here. The first thing we want to consider is that we're going to need to get our variables together. We're going to get our constants together. Over here, we have a negative 15 and a plus 4. So I'm going to go ahead and combine those like terms. We're going to end up with an equation that says 10x, and then minus 15 plus 4 is actually minus 11. And that's going to now equal 4x minus 5. Okay. Now I'm going to continue to just try to get the constants together. So over here, I have a minus 11. I'm gonna get rid of it on this side by adding 11. And remember, when we if we do something on one side of the equation, we have to do the exact same thing to the other side of the equation. So if we continue working this, I'm going to add 11 so that we can basically cancel it out on this side. But I have to also add 11 to this side. Now, we're not adding it to the 4x. We're adding it to the negative 5. So now my equation says 10x equals 4x. And then negative 5 plus 11 is plus 6. Now at this point, I need to get my variables together on the same side. Well, I have 10x over here. I have this constant over here, so I'm going to leave it. I'm going to remove this 4x. Well, the opposite of 4x is to subtract 4x, because 4x minus 4x is 0, so basically we cancel it here. But you also have to subtract 4x on the left side. Now my equation says 10x minus 4x is 6x equals 6. And probably at this point, you can see that 6 times 1 equals 6. But just to finish out how we solve equations, when you have a variable multiplied by a number, you do the inverse, the opposite of multiplying, which is to divide. We divide both sides by 6. And finally, we see that x equals 1, because 6 divided by 6 is 1. All right. That's going to be the end of part 1 of the review.